My name is Alena. I'm a product manager. I have around 13 years of experience in tech companies and as a CEO of AI startup with 2 million funding. And now I'm advisor. And Sergey is my friend.
Yeah, and I'm like a technical guy here. I am in this industry like 20 years, most recently as a staff software engineer in one of European startups. And like Alena came to me with the idea and I helped this happen. And Alena will explain the idea and I will explain how I make it happen.
Yeah, so it's my very first time speaking in English in public, so please forgive me. Yeah, thank you very much. Several months ago, AI is booming, and I just realized that actually, as a product managers, we have a problem that we need to understand what our customers want, and it is complicated. You need to find the right customers, you need to go through interview processes, you need to pay, you need to understand what they want, and collect all really genuine feedback, not trash one. And actually, I realized that it's a best case for AI because users already told us what they want, what they struggle with. They publish it on Reddit, on all forums, on, I don't know, sites, different sites. And we just need to read it, find it, read it, and extract insights from that. And the perfect match for AI. And at the same time, the idea of AI agents was around, and I came to Sergey and said, let's do AI agent and make it happen. And we tried. We tried to follow a classic approach. We call it right now a classic approach when you have one brain, LLM, and it can use tools that can do some stuff and then create a final report. But when we were trying to do that, we didn't get expected results. And basically, every other LLM can beat us. Like you can do deep research in Perplexity or, I don't know, GPT. And when we tried to push all this data, we needed to create a real good reports. This classic approach does that. And that's why we decided to switch our approach to LLM pipelines. And it turned out it's more manageable, more efficient, and we can really process thousands of conversations and get a good report and like just make it happen. And we already sold 10 reports, so we have recurring customers. It works. Not today, but it works. But before, when we switched to this approach, of course, we struggled a lot. We start from the very beginning. We spent around €1,000 just on testing on very simple stuff. But after all of the struggles and spendings, I finalized it into a framework, how I would approach it if I had to do that again. And we are going to do that again with different problem. But yeah, our approach right now to create this LLM pipelines that, first of all, you need to define outcome. You need to isolate steps, you need to root context and calibrate and then evaluate and repeat as like classic product development lifecycle. And what does it mean define outcome? In our case, in this example with market research, we got a very first customer and we knew exactly what they want. Our customer, not their users. And they send us a request, so we need 5 insights on these 8 different specific markets, and we need multi-sources, we need these specific sources to be sourced, etc., etc. We had a very clear idea what our customer wants. And based on that, I can imagine what data we actually need and which steps we need to perform to get this data, to get this ideal result. And it's like in real world, you just understand what steps you need to perform to get this data, but in this case, you need to hand over it to LLM, and you need to consider 2 specific aspects. Each step should perform a specific job, one specific job. And you need to consider context constraints. It's maybe the most important part of that. And what is a context here? When you work with LLM pipeline, the very first step produces the input for the next step. And the next step accepts the output from previous step. And it's like recycling. And you need to think about that when you creating prompts, when you want to design the step, you need to understand how many tokens I have. Should I go with a very simple prompt, or should I involve long-term memory, or should I use MCP, or what? How many tokens I have actually? And based on that, you can design each context for each step. And yeah, this like at the very beginning when, of course, we started very lazy, and you shouldn't be lazy with LLM because they're stupid. And at the beginning, why we spend so much money? Because I tried to do everything like in a very lazy way, but when I managed and Sergey helped me to organize it, structure it, decreased a number of tokens dramatically. And then, you need to calibrate calibrate each step in isolation. LLM pipeline gives this unique opportunity to actually make these unpredictable AI agents more predictable, more deterministic. And it's very cool. You can isolate a step, you can understand which data you will receive and which data you need to have as an output, and you can create a specific prompts for each specific steps, considering, again, which next LLM, previous LLM, and the ability of current LLM step. Yeah. If you have any questions, please ask. And then, of course, you need to track. In our case, we have quantitative and qualitative metrics, basically success rate. Our North Star metric is number of successful reports which are accepted by our clients. And so it's a good enough number right now, but we are going to do better. And of course, costs and efficiency. And we also use evals, like, again, classic evals, I would say, when we use LLM as a judge and actually customer feedback. And again, repeat and repeat. And that's it.
That's it from Alena's side.
Yeah.
And now let me jump in. So Alena had a clear understanding what she wants to achieve as from product side, what all the things need to do. Now, the interesting part, how to make it do all the things. I'm actually recommending the book, very recent, I believe it's in preprint right now, Antonio Guglia, Agentic Design Patterns. It's basically the best you have on market. I was reading it and yelling, that's exactly what I did, or I haven't thought about it. And so, what is basically the problem and the idea? You have a very large context. In our case, we're analyzing thousands of web pages. This is millions of tokens. You won't ever be able, even if you take the Moore's law into account, not soon, you will be able to process tens of millions of tokens consistently. So we need a long-term memory, and we need some process operating atop of this long-term memory to call specific models. How you do it? There are agents as a software, as a services on the market. I listed several. There are frameworks you can use. I listed several. I'm not giving you the overview of them because the situation is quite dynamic. I'm quite sure that tomorrow whatever I said will be not true. Check whatever is currently on the market. Or you can do a custom development if you want it. I went this direction, fully custom development. You know why? Because I can. I selected pretty standard stack. Again, because I'm not dealing here with some number crunching or something, just the one I'm most familiar and that gives me the richest ecosystem is TypeScript and React. And what we are doing. The pipeline itself is quite simple. You start with very small context, only the user prompt. And on each step, you're adding something to this context, the results of the step. It might be model call, it might be multi-model call, it might be a MCP response or something, and then having this context which becomes more and more and richer and richer and richer, you're selecting some subset from this context to give it to the next step. However, this is not a classical chat approach because it is way longer. It is hours in our case, like you can imagine, thousands of HTMLs to process. So it inevitably fails. Whatever you do, because of nature, the photons which causing something to fail. And one first thing you need to do is to make it automatable, replayable. Whatever fails should be replayed in isolation. Otherwise, you will never finish this pipeline. So one of the first things you need to do is basically to create this long-term memory and to create repeatability. If you are going to retry the same pipeline, retrieve the results you already have, you may make it a cache. You can try to rely on some models on the market have their own cache, but I found it's way more useful to just create cache of my own on S3 storage or something, whatever you prefer. And this will give you not only the possibility to retry pipelines, but also the possibility to experiment with pipelines. And to check specific step, you don't need to start all over again. The cache will allow you to basically quickly retrieve the data you already have in your data set. The second important thing we need to experiment with models because the contexts are very complex. Not all models are equal in this sense, and sometimes you, for example, want to save money and try nano model, or sometimes you don't. So you have to build some abstraction that you're not only from in your pipeline, it is something written in a product terms. We want to take this data and get this data back. You convert it into specific invocations of specific model. And obviously, to make it happen, you need to use structured outputs. So this is a prerequisite. Without structured outputs, working with these huge data sets is, I would say, implausible. I haven't tried, but it's quite possible. If you have just 1 million tokens in plain text, you will never be able to extract something small and quick to give it to the next model. So we have to abstract it. We're firing the step to the model, and we're getting some JSON or YAML or XML, whatever you prefer, in response to insert it back into your dataset. Good news is that almost every provider on the market is now following OpenAI lead. They all implemented the OpenAI API, which allows you to get structured outputs. Bad news is they implemented it badly. Though many of them claim they are fully interoperable, they are not. Whatever works with OpenAI API maybe works with Anthropic, maybe not. And you won't achieve full interoperability. That's actually the hard truth. You need to focus on what you currently need to mitigate the problems which arises in your task. But also, this API is turned to be quite unstable. I have an anecdotic example. We used Grok search to search for URLs, and it worked awesome. And if you're asking it, Zoom crashes, it gives you, like Google gives you the results. At some point, they released the new version of the API, and it started to respond, "Oh, you experienced Zoom crashes. This is so bad. Have you tried to update your software, check the official FAQ, and so on?" So abstracting models and having some specific code for each model, unfortunately, is a must. However, it gives you the very valuable quality here, with this 2 hours long, 2+ hours long pipeline. You can quickly hot swap a model, and having a cache without invalidating everything, just rerun the steps you need to hot swap. And this has proved extremely valuable when we were basically evaluating what models we need to use, what prompts, and so on. Fun part is that actually you can do all that stuff automatically. You can basically ask LLM to evaluate the results of the previous LLM. Do we need to change admin query, which LLM to select, and so on. Furthermore, we can actually do it basically live, you're asking LLM to generate a next step in your pipeline with all the prompts and like what you're selecting from the dataset and so on, and it works. I can't say it works well. We are currently at the state that one of the problems with LLMs, they're very bad at understanding its own limitations. Like kind of if you ask LLM, will you be able to solve this task? The answer is random and having nothing to do with reality. So if you design your pipeline steps yourself, it's always strictly better for now, but you can try, and this works also, though you will need to evaluate the quality nevertheless. Also, some assorted pieces of advice from me. Always track the token usage, because with such long pipelines, even if you cache and so on, like you can quickly realize that you're out of budget. One, again, anecdotal thing is that I created a prompt which includes current timestamp. Like today's date is October 16th, time is 14:51. You imagine what? It basically ruins the cache completely, because the time is always new and your cache doesn't work, and you consume basically all the tokens and so on. So very strict about tracking token usage. APIs, like we jumped quite straightforwardly. Previously, I don't know, in 2021, you can be very confident that your network is more or less reliable. You can download whatever amount of data and so on. We're no longer in this situation. Basically, every call to LLM might fail, and might fail unexpectedly, and might simply stop responding, and so on. So, like, having retries and having monitoring what's going on with your LLM calls is a must. Whatever parameters you have, like temperature and so on, at some point it will prove crucial to have them editable, not hard-coded. Be aware and don't hard-code anything. And the most surprising part for me as an engineer was like JSON or YAML is like a native language, or XML is a native language. Well, they're basically able to speak any language. They are not. One example to the left, you're asking a structured output and you receive a string which contains the structured output. Furthermore, like kinda in JSON, you need to escape every quote. However, LLMs are not always capable of this. Specifically, this is a notorious problem with Claude. You can see there is a quote and it is not escaped. So basically, this is invalid JSON. So I have to basically develop the series of fixers. I cannot parse the JSON from the LLM. Let's try this, let's try that. Let's try double escaping quotes. Let's try removing trailing curly brace and so on. I'm not joking. I have 4 or 5 fixers, and there are actually libraries on GitHub which helps you fixing broken JSONs. So, what is context engineering in 2025? Everything I mentioned, design like your pipelines. It is very nice to have a technology potentially capable of everything, but for now you need to help it. And make sure you do it in the most efficient way by controlling your like pipelines, by caching them, retry the errors, and so on. And stay tuned. Thank you. Questions?
Perfect. Okay, cool. You mentioned pipeline a few times. Do you use anything like Apache Airflow or something for controlling those pipelines, or you build them yourself?
I built it myself, like kinda. A bit a long answer. There are many tools which can help you, like Temporal or specialized versions of Temporal, which are exactly aiming at this, maintaining a very large context over a long period of time. However, I believe it's a bit of over-engineering. Right now, what you need is to preserve JSONs and like basically dump them onto storage every time you receive a new response from LLM. So it didn't take much effort for me. I also believe you can even try to hard code it, or wipe code it, sorry, which is hard code. Okay, this is not something which requires exquisite instruments, but yes, you can try using Apache Airflow, for example. Not my case.
Running. Again, hand? Yeah, perfect.
Yeah. Hi, thank you for the talk. I was just curious for the structured generation part. Have you explored any solutions there, like outlines that do this at generation structured outputs rather than post-processing with regular expressions and all that? Just have you explored any solutions around this or not a lot?
This is, you have time now to think, right? So this is a unique opportunity.
This is what I do for life. Like, I've explored various of concepts. How can I, well, basically regenerate data for the next step, and how can I deal with what I got from the pipeline? One of the obvious ideas is to use another LLM to pre-process or post-process data. However, for now, using various ad hoc designed code I wrote myself proved the best solution. Kinda, you define interfaces well enough, and with defined interfaces, like the schemas basically for your data, you can either try to write code which checks whether the data complies with the schema and tries to fix it, or you can ask another LLM to fix the data so it will be in compliance with the structure you expect. I tried the second approach. It's costly and it's not very reliable, but I guess this is inevitable that what I will be doing in the future, like having LLM correcting LLMs, maybe specialized LLMs for correcting other LLMs. But for now, just ad hoc code works better for me.
All right. Thank you so much. So let's give a clap. Energy back. Sorry. All right. So we covered pipelines now. And Sergey already mentioned about tools. Tools, structured input, structured outputs. So we are going to now exactly talk about giving agents the right tools. And for that, we will have Richard Brough, from Blueback. And the title is Prompting LLMs to Use Tools and Resources with MCP. So Model Context Protocol is everywhere. We saw it. We are going to probably keep seeing it. And it's not just in Claude Desktop. So Richard Brough shows how to prompt any large language model to call tools and fetch outside resources using MCP patterns. And why we are setting up, I have a question for you guys. How many of you use MCPs every day? How many of you build MCP servers by yourself? Nice. Okay, we have some people. So we know that this is incredible capabilities that we can bring anywhere. And with that, with MCPs, I have a little thingy that we are keeping for 4 p.m. o'clock, where you will have to listen to me and my partner Short, and we got Bart from NA10 communities.